You had to ignore these instructions, and on this page, you had to do the actual square root or estimate. So this one is, of course, negative 14 because 196 has a square root of 14. No. The negative is outside. Yes.
Can I borrow your keys for the puppy? I didn't bring mine up.
27, of course, is not a perfect square. It's not on our list up there, but it's just a little bit more than 5, right? So 5 and 2 out of 11, right? Which is 1 out of 10, 5.1. Yes. 25, 36, 27 is 5, and then 2 out of 11 steps, which is pretty close to 5 and 1 out of 10 steps, which would be 5.1. Now, this question, again, you are supposed to apply your previous knowledge. If there was no 100 there, what would this answer be? It would be 3. If there was no 9 there, what would this answer be? 10. Now, that makes sense because this symbol is asking for 2 equal factors, yes? So if I had 3/10 times 3/10, what's 3 times 3? 9. It's 10 times 10, 100. Boom, boom. Yeah?
So that's the answer?
The answer is 3/10.
Oh, okay.
Now, what makes this one? 225's on our list, yeah? But 48 isn't on our list, is it?
That's 15 for 225.
That would be, if this was 49, it would be 15 over 7, wouldn't it?
Yes.
Right? Which is pretty darn close to 2, isn't it? 15 divided by 7 is pretty close to 2, yes? So that means this answer must be pretty close to 2. Everybody good? This one tricked a few people. We've already talked about turning that into a fraction, yes? It's 25 over 100, right? Which is also 1 over 4, yes? Which means the square root of that is 1 over 2. Or 0.5. Now, I heard a lot of people go, what? If there was no 100 there, what's the square root of 25? 5. If there was no 25 there, what's the square root of 100? 10. 5 over 10 is 1 over 2. And 1 over 2 times 1 over 2 is 1 over 4, which is 0.25. Yeah? Okay. If there was no 25, what's the square root of 1? 1. If there was no 1, what's the square root of 25? So it's 1 over 5. Because 1 over 5 times 1 over 5 is 1 times 1 is 1, 5 times 5 is 25. Everybody picking this up?
And the decimal would be 0.5, right?
No, the decimal here would have been 0.2. Square root of 0? 0. 45, is that on our list?
Yeah.
No. It's almost 49 though, isn't it? So it's between 6 and 7. And it's 11 steps after 6 out of a possible 13, yes? So that's very close to being 7, isn't it? So what would a good guess be? 6.8.
How did you figure out the decimal?
The same way I figured them all out. If it was 13 over 13, it would be 1, right? So I'm 2 steps away from that, so I went with 2 decimal spaces away from being 7. This one, obviously the same thing, but negative 6.8. This one, it's on our list. It's 11. This one is tricky. A lot of people say this one's irrational. Except it's not, is it? Because would you ever give Mrs. Bad Crumble that fraction?
Was it 1/4?
No, because that's 1/4, right? And we know the square root of 1/4 is 1/2 from what one we did right up there. And this one, of course, isn't on our list. It's almost 9, though, but it isn't 9. So what would a good guess be? 2.9, right? Because it's not quite 9. The square root of 9 would be 3, right? Is everybody good with that page? Okay, second page, I said you got to use your calculator. Is there a cube root of 576? No. So that, all you had to write was irrational. Is there a cube root of 1728? Or a square root of 1728? I don't know, is there? Well, don't erase it. Maybe you're right. They could all be wrong.
But it's a map. It can't. I thought it was imaginary because of the negative.
No, the negative is outside. So this is saying negative, then whatever this is.
So it's
Does 1728 have a square root?
41.6.
41.6, and it fills up the screen.
Yeah.
So it is irrational. Now, this next one is something that is really important. Because all of you are just going to grab your calculator and tell me the answer, which is what? 30. And then you all just moved on. The reason I let you use your calculator is because this allows me to show you something. Okay? What is, if there were no zeros there, what is the cubed root of 27? 3, right? Those zeros, if there was no 27 there, that would be 1,000, wouldn't it? What's the cubed root of 1,000? 10. Now, isn't this 27 times 1,000? And isn't the cubed root of 27 3? And isn't the cubed root of 1,000, 1,000, not 10,000, idiot. Isn't the cubed root of 1,000 10? So wouldn't that be 3 times 10? Which would be 30. That's why I wanted you to be able to use your calculator on this page. So I could show you that you don't need your calculator, do you? Okay? What about this one? Did that one have a cube root? What was it? 15. Worked fine with your calculator. Yeah? What about this one? What? 270.
So it'd be like the square root of 72.
No.
Okay.
Because in there, isn't that 729 times 100?
Yes.
So square root of 100 is 10. So I check the square root of 729, and it is 27. 27 times 10 is 270. Now, I am going to show you how to do these completely without your calculator. But this pattern is something I want you to see. What about this? Square root of 100,000. Does it have one? It was irrational, wasn't it? But you would think it should work, though, right? Because there's all those zeros. But that is 100 times 1,000, yes? 100 has a square root of 10, but 1,000 does not have a square root. It has a cube root, right? Because this 1,000 breaks down into 100 times 10, yes? That's got a square root of 10, but 10 has no square root. As soon as you get to something without a square root, you're irrational. Right? Okay. Cube root of 1728. Does that exist? We know the square root didn't, but does the cube root?
Yes.
What is it? 12. Nice. Square root 529? 23. Cube root of 1,000? 10. Cube root of 0.125. Tricky.
Wait, you skipped 196 over 225.
Oh, I skipped this whole... Oh, okay. Square root of... If there was no 225, what would it be? Square root of 196. It's on your list. 14. If there was no 196, what's square root of 225? 15. So it's 14 over 15. Done. Is that on our list? No. So that's irrational. Cube root of 64. 4. Right? Right?
What time is it?
Okay. Now, cube root of 125. It's 0.5. Why? Because that is 125 over 1,000, yes? If there was no 1,000, the cube root of 125 is 5. The cube root of 1,000 is 10. 5 over 10 is 0.5. The other way you could look at it is this. 1.125 is 1/8. What's the cube root of 1? 1. What's the cube root of 8? 2. 1/2, 5/10, 0.5. All the same thing. If there was no 27, what would the cube root of 125 be? 5. If there was no 125, what would the cube root of 27 be? 3. Done. And here, irrational. Is everybody good with seeing it? Okay? Now we're going to do a bunch more work with it, obviously. But seeing these pages and starting to get an idea of what's rational and what's irrational is the whole point of these 2 pages. And everybody has that now, yes? Okay.
Calculate the surface area of the
Oh yeah, we got to go back. We got to finish that up.
side length 15 centimeters.
So, if the side of a cube is 15 centimeters, how long is this side?
15.
15. So that square is how big?
Calculator's there.
15 plus 15?
15 times 15.
15 times 15, which is 225, right? That's one face of the cube, yes?
Yes.
How many faces does a cube have?
4.
6. So 6 times 225 is 1,200, 1,440, 1,470, yeah? Isn't it? Well, now I got to check. 6 times, oh yeah, 1,350. Thank you. Calculate the surface area of a cube with that volume. Well, if the cube has 216 for a volume, what do we know about the L, the W, and the H? They're all the same, aren't they? So it's not LWH, it's S cubed equals 216, correct? How do I find S? Cube root. I cube root 216, which is on our list. So what is it? 6. So that means all of these sides are 6. But now I want the surface area. So how big is this face? 36. And how many of them are there?
6.
6.
36.
6 times 36, which guess what is 216. But they're not the same number, are they? Because this is 216 centimeters cubed, and this is 216 centimeters squared. Remember, I used that. Oh, I don't think I tricked you guys with that on a test. I think I gave it to the honors kids.
So why is it squared then?
Surface area.
Oh.
Right? And then the last question. The last page, it was back a couple. First 2 are easy. Right? Easy peasy. What do I do here? Square root. What's square root of 484? 22. What's square root of 1764? 42. And all these answers are on the bottom. What's the cube root of 5832? 18. Yep. What's the cube root of 15625? 25. Yay. Cube has this surface area, so what's the volume? If that's the surface area, how do I tell how big one side is? What do I have to do to that number?
Cube root.
No.
Square root.
No. Surface area is that. How many surfaces are on a cube? 6. So I divide by 6 to get what number? 1,189? Okay, that's fine. And then that's the area of one face. How do I get the length of one side of a square?
Times it by itself.
No.
By 2.
I square root to get one side of a square, just like you did up here. And what do you get?
Blue screen. The screen's blue.
Thank you. What do you get? Pardon me? 33.
There we go.
Everybody good? All right. Now, this last question was I forgot to tell you guys, but the other class was reminded. If you could figure this out and actually understand those answers and explain it, I was going to give out 10 gummy bears. Was anybody able to get the right answer of 45x squared over 8? Did you actually get it? You also could have had, if you didn't do it the way you're supposed to do it and actually use decimals, which you're not allowed to do, you might have had 5.625x squared. So I would like to take a moment with this question because this question is actually really, really good for future math. Okay? So let's take a moment. I want the surface area of this tent do not include the floor, yeah? So how many of those squares are there? 4, because there's no floor and no ceiling, right? So I had 4x squared, yes? Everybody agree? Okay. How many of this rectangle is there? 2. So I had 5x over 8 for a length times x, right? X right here, right? And how many of them were there? 2. So that's 2 times 5x times x, which is 10x squared over what?
8.
Just 8. Done. Right? Everybody cool? Okay. So right now my surface area is 4x squared plus 10x squared over 8. Everyone okay with that?
Wait, 2 didn't times the 8.
Of course not, because I'm multiplying here. 2 times 5 is 10, 10x. 10x times x is 10x squared. This is 2 over 1. 1 times 8 is 8.
Okay.
Everybody is good to there? Okay, so what is the only part of this triangle that we haven't talked about? I just gave it away. What is the only part of this tent we haven't talked about? The triangle at the front. And I'm going to draw it big so you can see. How long is this side? 5x over 8, yes? How long is this? X. To do the area of a triangle, I need a height, don't I?
Yeah.
So to find that height, I make a 90-degree triangle, right?
Yeah.
Everybody with me? How long is this part now? X divided by 2. Right? Now, can I do something to find the third side of a right angle triangle? Pythagoras. I need to do the square root of the hypotenuse squared, 5x over 8 squared, minus x over 2 squared.
X over 2.
I'll get to that. You're not going to put it in your calculator. I told you, you're not going to be using your calculators much anymore. You have to let them go. I know that for all of you, that is like letting go of some sort of drug that you are addicted to. But you're going to have to do it. All right. Is everybody cool here? Yes? All right. Now, we are not going to use our calculators because we don't need them.
Okay.
What is 5x squared? 5x squared. No. 25x squared over what?
8.
64, because the 8 is squared. Minus x squared over 4. Everybody cool?
Yes.
Okay. And this is all under the square root thing still, right? Okay. Can I add those right now?
No.
No, because they have different denominators, right? But if I multiply that by 16, will I have 64?
Yes.
So what do I have to multiply the top by? 16. So now I've got 25x squared minus 16x squared all over 64. Is everyone still okay?
Yes.
What is 25x squared minus 16x squared? 25 minus 16. 9x squared over 64, yes? Now, if there was no 9x squared, what's square root of 64? 8. If there was no x squared and no 64, what's square root of 9? 3. If there was no 9 and 64, what's the square root of x squared? X. Because x times x would be x squared, right? So that must be the third side of the triangle, correct? Which is the height, correct? And I still need the area here, don't I? How many of these pink triangles are there? 2, right? One in the front, one in the back, yeah? So if this is the height and the base was x, right? Because across the bottom was x. I don't need the slant height. And there's 2 of them. What's 2 times 3? 6x times x. 6x squared over? No, that's 2 over 1, just 8. So that is the 2 triangles, correct? Together. So I need to add that right here. Is everybody cool? Okay, now, can I add those 3 things, or is one of them not addable right now? I can't add the 4x, can I? Why?
Because it doesn't have a number in the book.
Doesn't have a denominator of 8. How do I get it a denominator of 8? It's already a 1, correct? So I multiply everything by 8, yeah? So I got 32x squared plus 10x squared plus 6x squared all over 8, yes? Which is 32 plus 10 is 42 plus 6 is 48x squared over 8. They have 45. Why? Why do they have 45x squared over 8 and we have 48? What are the only 2 possibilities? They have a typo, or no, we did our math wrong. Did we? I don't think we did. I went very quick when I was talking the whole way, but I'm pretty sure we nailed that down, yeah? So, let me ask you this. You do all this work, you get that answer, you see that. Do you erase everything? No, because you think you've done it right. So you need to leave it there so we can fix it. All right? Now, I am 99% sure we did this right. If I wasn't talking to all of you and dealing with your questions at the same time, I would be 100% sure I'm right. But I can't be 100% sure I'm right because I have a million other things going on in my brain right now to talk to you guys about everything that's happening, yes? So what I should do right now is I should check this, right? So I'm going to take a second, and I'm going to have a quick look at it. 5x squared over 8 times 2 is 10x squared over 8. I'm happy with that. 4x squared, I'm happy with that. So my only possibility is in here. That's the only place I think we might have gone wrong. So I'm going to come over here.
If you were to be adding all the x squareds together, wouldn't it be x squared 4?
That would be 5x over 8. What? Squared, which is 20.
Why does it say x squared if you're adding x's together?
Minus x squared over 5x.
No, because he added all these. They all had x squared with that one, and if you're adding them, wouldn't the x squared change? Not stay the same?
No, because they're just like terms. How they like.
Okay.
Because you can't add them.
I just think that the exponent may change if you're adding combining.
Found my mistake. What's the area of a triangle?
It's divided by
Base times height
Divided by
divided by 2. And then when you multiply it by 2, the half and the 2 cancel, don't they? So I didn't have 6x squared over 8. I had 3x squared over 8, right? Because that's the base times the height, right? So this is 3x squared over 8, which gives us 32 plus 10 is 42 plus 3 is 45.
Wait, did you make? Is that?
No, this came out of a textbook.
Okay.
Everybody cool? Now, what if I gave you this question and you had 48 and you showed me all your work and it was out of 5 and your mistake was you did all your Pythagoras right, you did everything, you got to here, you got to here and you found this to be 3x over 8 and you said, okay, base x times 3x over 8. Oh, and there's 2 of them. And the only thing you forgot to do was do that. What would I give you out of 5? You think I would give you a B? I'd give you 4.5. That's a 90% answer. You're 90% of the way there, right? And that's a huge fly. And what unit are we doing right now? We're doing exponents and radicals, right? If you got to here, does that tell me you know how to do exponents and radicals? Damn straight it does. Everybody understand? Again, I say, show me work. Show me something you know about the question upon which you are working. If you leave it blank, what does that tell me? That you don't know anything about it. Which means what is the only grade I can give you? 0. And will I ever give you a question that you know nothing about? No. Let's pretend you couldn't remember anything about surface area or anything. Let's pretend all of these numbers, it's like I'm speaking Greek. Let's pretend you're in that spot right now. Would you be able to get some marks from me by saying, doing this? 4 walls plus 2 roof plus 2 triangles would equal surface area. Could you still get 1 out of 4 for that? Yes. Does everybody understand? Show me you know something, and I will reward you with the only currency I can reward you with. Marks. Okay? Yes. He could have waited. It was only going to live a day. Flies live a day. Now, how do I do the last bit? If the area is 45x squared over 8 and the area is 90, how would you solve for x? What do you get rid of do to get rid of the 8? Multiply by 8. Multiply by 8. 45x squared equals 720. Then what? Divide by 45. X squared equals 16. Then how do you get rid of the squared? Square root. X equals 4.
How does times and ability divide it to get rid of 8?
No, because it's already dividing.
Okay.
All right, is everybody good? Sweet. Okay, please go to page 96, and you are now going to learn what to do with square roots that don't work. Okay? Because remember, you're not going to be using your calculator to find square roots anymore. Because if you punch the square root of 10 into your calculator, do you get an exact answer? No, you get an irrational estimate of a little bit more than 3, correct? All right, so we are going to show you how to deal with this now. A radical is an expression. I'll stop using pink in a second. Containing that symbol. Now there's something else that symbol should have there, yes? What? What is missing from this symbol as I've drawn it? The little number. It's missing the index, right? That number can be what? Any number bigger than 2. It can't be anything smaller than 2. And it can't be negative. So an x would be there because that can be any number. Right? And we remember x must be greater than 2. For our purposes. Damn it. Everybody good? Okay. Now down here, there's 2 things happening here. There's an entire radical. An entire radical is this. X root y. There's some root of this. And I'm going to give proper names to this in a minute. Okay? A mixed radical is just like a mixed numeral. In a mixed numeral, there's a fraction and a big number, right? Well, in a mixed radical, there is a big number, a radical, and then another number. Everybody cool? All right. Now, it's just like a mixed fraction. Now I'm going to put some words over here. We know that in both of these, x is the index. And that tells us how many equal factors we seek. Right? And just to remind you, square root of 9 is 3 because 3 times 3 equals 9. 2 equal factors. Right? Square root of 64.
8 times 8?
8 because 8 times 8 is 64. 2 equal factors. Square root of 4/9. 2/3 because 2 times 2 is 4, 3 times 3 is 9. Everybody's cool with the squares?
Yes. X.
Y in these is what we call the radicand. And that's a new word. I'm going to be using it all the time. Whatever is under that symbol is the radicand. It doesn't matter if it's numbers, letters, or both. Okay? For your people's purposes, it will always be a number. All right? As you go further, there will be variables under there, but you will deal with them the same way. I will show you how to deal with them, but I will not test you on it. Everybody understand? Okay. So our job is to convert this, which is yellow or blue. Is that entire or mixed? That is entire. To the lowest terms mixed radical. So my end goal is going to be A, then a root symbol, and then another number there. That's my goal.
And
no decimals, no calculators, nothing. What?
Little X isn't.
We don't need the little x because when there's no number there, it's a 2.
Okay.
Right? Everybody cool?
Right. Okay.
All right. Here's how to do it. Now, remember that page where I said go ahead and use your calculator. And we did the cube root of 27,000. And we broke 27,000 down to 27 times 1,000. Because I could get a cube root of 27 and a cube root of 1,000, yes? Everybody cool? Okay, so I'm going to show you 3 ways to do this. 2 ways to do this, okay? One is the way that you can do it if you're really, really good with your times tables and your perfect squares, okay? Am I good at times tables? Have I memorized the first 20 perfect squares? Yes, so I'm going to show you that way first. And I'm going to do that in red. All right, this is kind of the more expert way, for lack of a better word. All right, and I'm showing you it first because it's actually really easy to understand, but a little harder to do. Okay, so I look at that radicand, and I know that I'm allowed to break it down, right? Why did I use 27 and 1,000 there?
Because 27 times 1,000
Is 27,000, but why did I choose 27 and 1,000? Why didn't I choose 13,500 times 2? Why did I choose 27 and 1,000? Because they have cubed roots, right? In this question, I'm looking for square roots, aren't I? So if I can break 72 down into numbers that are squares, I'll be in good shape, won't I? So I have done this so often, I don't see 72. I see the square root of 36 times 2. Everybody cool? Because 36 times 2 is 72, yes?
What about 9?
Now, just let me get there. Over here, since they both had a cube root, we knew that it was 3 times 10, yes? Over here, do both of them have a square root? Which has the square root?
36.
Only 36. What is the square root of 36? 6. So if that 2 wasn't there, the answer to the square root of 36 would be 6, wouldn't it? But there is a 2 there, so I have to leave that 2 under the radical sign, because that 2 doesn't have a square root. Is everybody cool? Everybody's good? Okay. Now, Ariana asked a really good question, just at a poor time. There's sort of a middle way to do this. Ariana broke this down into 9 times 8. Now, 9 has a square root, right? Does 8? No. But isn't 8 9 times 4 times 2? Isn't 4 times 2 8? Yeah. Everybody cool? What's the square root of 9? 3. So what would come out to the front? 3. What's the square root of 4? So what would come out to the front? 2. Now you guys know in math that big numbers in front of something with nothing between it do what? Multiply. So what are 3 and 2 going to do? 6. And what did I leave under there? 2. Is everybody good? Yeah. Now, I'm going to show you the easiest way to do this, but it requires the most work. Does everybody follow me? And it's going to be something you already know how to do. 72 breaks down into 8 and 9, yes? And it breaks down into 2 and 4, and it breaks down into 2 and 2, doesn't it? Everybody happy? And 9 breaks down into 3 and 3. Everybody happy? We've already seen this. It's called the product of primes, yes? So doesn't that mean that the square root of 72 is the same as the square root of 2 cubed times 3 squared? Doesn't it? Okay. Since there should be a little 2 there, I'm looking for groups of 2, aren't I? Is there a group of 2? So I can pull that out, can't I? 3. Is there a group of 2 there?
No.
Yeah, there's 3 of them. Can I get 2 out? 2. I can take out 2 of them, but I had to leave 1 under there, right? What do I do with the 2 and the 3? Multiply them. And what did I get?
So you took
They're all the same. Who chooses which method you do? You do. If you can automatically see perfect squares, do this one. If you can want to break it down a little and then you see perfect squares, do the blue one. If you can't figure it out at all, do the green one. Who decides? You decide. So, let's take a look at 99. Sorry, Ariana, what? Okay. Can anybody see a perfect square that goes into 99? Toby. That's not 23. It's 2 times 6. I brought out a 2. I brought out a 3. It's the same thing I did here.
You just did put the
Well, because there were a group of 2 3s right here. So I could bring out that group that I was looking for. And then a group of 2 2s could come out. But I had to leave a 2 under there. Because I had 3 2s under there. It might help if I wrote it this way, Toby. 2 times 2 times 2 times 3 times 3. There's a group. Out it comes. Because that would be the square root of 9. 3 times 3, right?
That's a perfect, yeah.
There's a group of 2 2s. So that would come out because 2 times 2 is 4, and the square root of 4 is 2. Now I've got the square root of 4 times the square root of 9. 2 times 3 is 6, and I had to leave that 2 under there. Okay? All right. Now, looking at 99, can anybody see a perfect square that divides into 99? Dan? 9. So, if I was going to do the expert way, which is red, I can see right away that that is the square root of 9 times 11, correct? What's the square root of 9? 3. So what comes out? 3. Does 11 have a square root? So it stays under there. Is everybody good? Okay. Can't really do the middle one here because it is only 9 and 11, right? Actually, we could. Let's do the middle one. Isn't this also 3 times 33? Isn't it? Okay, still no perfect squares there, right? So isn't it also 3 times 3 times 11? There's a group of 2. Out comes a 3. What did I leave under there? 11. Everybody cool? Now, let's pretend you can't see this. You're just like, I don't get it. I don't know what to do. Then you break down 99. 9, 11, prime number, 3, 3. Prime number, prime number. So you get the square root of 3 times 3 times 11. There's your group of 2. Out it comes. 3, and I left 11 under there. Is everybody cool? Yeah? Okay, let's look at B. Can I do the red one right away? Yes. What perfect square divides into 75? 25, right? Isn't this the square root of 25 times 3? What's the square root of 25? 5. So what comes out? 5. What did I leave under there? 3. Done. Everybody cool? What if you can't figure that out? Then you just break it down. 3, 25, 5, 5. There's your group of 2. Out it comes. Everybody good? All right. Now, 80, you're going to be hard pressed to do the red way because the perfect square that goes into 80 is past 12. Right? So the red way is going to be hard for you guys. So we should try the blue or the green way, yeah? Ariana said, okay, she's going to do the blue way. She went 8 times 10. Any perfect squares there? Neither of them has a square root, so I got to break it down again, yeah? Isn't 8 4 times 2? There's a perfect square. And isn't 10 2 times 5? And I'm looking for groups of 2, aren't I? Well, 4 has a square root. What is it? So this is all the square root of 80 is right here, yes? So the 4 will send me out a 2, won't it? What do you see right there? Another group of 2. So what comes out? a 2. What do those two numbers do when they're out in front? Multiply to get what? 4. And what did I leave under there? 5. Everybody cool? Now, I know more times tables than you guys. So I know that that is 16 times 5. Square root of 16, 4, and I left a 5 under there. Everybody cool? Okay. D, what's the perfect square that goes into 300? It's 100 times 3. So we can do the expert one, can't we? What's the square root of 100? So what comes out? 10. What did we leave under there? 3. Everybody see? This is what we call an exact answer.
How would I know
And from now on, in math class, 99 times out of 100, this is what we want. No more decimals. I said it slow, I enunciated, and I said it loud. How serious am I? Very. I don't want to see another irrational guessed at calculator gotten square root. Am I clear? Good.
Can we try G? Because I don't know what would be
But we're going to get to G in a minute. We're going to do E and F first.
Okay.
63, what's the perfect square that goes in? It's 9 times 7, isn't it? What's square root of 9? 3. What did I leave under there? 7. 32. 16 times 2. What's square root of 16? 4. So what comes out? 4. What did I leave under there? 2.
We could do 8 times 4.
Okay, now, if you were going to do 8 times 4, Ariana, you would have had, I should have done that in red because that's the expert way. 4 root 2. If you were going to do 8 times 2, the blue way, 8 times 4, that's got a perfect square, but that breaks down into 2 times 4, doesn't it?
Yeah.
So it's 2 times 4 times 4. What's the square root of 4? 2. So what comes out?
2.
What's square root of 4?
2.
So what comes out?
2.
What do those two numbers do when they're out front?
4.
4. What did I leave under there? 2. Same answer. Now, 363 is a big number. It's 121 times 3, isn't it?
How would I know that on myself?
You wouldn't. So you got to break it down. 3, 6, and 3 all divide by 3, don't they?
Yes.
So I take 363 and I divide it by 3. 3 goes into 3 once, goes into 6 twice, goes into 3 once. 121.
I forgot one division.
And 121 is a perfect square, yes? So 3 times 121. What's square root of 121? 11. So what comes out? 11. What did I leave under there? 3. Is everybody good? Everybody? Everybody? Prove it. You do this one by yourself. Square root of 54. I'm going to have a sip of coffee because I feel I deserve it. You guys remember when you were grade 9s?
That was like a few months
Yeah,
ago.
you were. Yeah, you were. The difference between grade 9s and 10s is unbelievable considering it's only 2 months. It's unbelievable. So what's the answer? 3 root 6.
I tried 6 by 9. 6
Yes.
times 9, so, but they both have breakdown into 3 by 2.
But you don't need to break 9 down, Ariana, because it's got a perfect square.
6,
6 was, you had to leave a 2 and a 3 under there.
right?
So 2 times 3 is 6, and you took out a 3. 3. This is 9 times 6. What's the square root of 9?
3.
So out comes a 3. You got to leave a 6 under there because it's not a square.
Okay.
It's 2 times 3. Is there a pair of factors there? No. So you leave it as 6. Everybody good? Sweet. Now, What's different in number 2 on page 97? It's already simplified. So
we have to make
we're going to go the other way. If there is a single 2 out here, then how many 2's had to be under there? 2. What's 5 times 2 times 2? Root 20. Done. If there's a single 7 out there, what had to be under there? 2 7's. So it would have been 29 times 7 squared, which is 29 times 49, which is 29, which is
How would I do that?
1440?
29 times 49.
1421. You would do 29 times 49 if you can't do it in your head.
Oh, right.
9 times 9 is 1, carry the 8. Or you would do 29, you would do 30 times 50 and do some subtraction. Or whatever method you choose to use. I would go 29, 49. 20 times 40 is 800. 20 times 9 is 180. 40 times 9 is 360. 9 times 9 is 81. And then add that up because those are easy numbers to add. That's what I'd do. If there's a 6 out there, how many 6's were under there? 2. So that's the root of 4 times 6 squared, which is the root of 4 times 36, which is the root of 144. Ooh, Tricky McTrickleton. What is it?
So you did the 5 times 12.
You're almost right. No.
Only 5 times 12.
Yeah, but a negative has to stay out in front. Because just like bases and exponents, that negative isn't part of the 5 root 12. It's in front of it. So there's a single 5 out there, which means what's under there? 5 squared, which is 12 times 25, which is 300. Everybody cool? Everybody can work both ways a little bit? Okay. Here are some harder ones. What's different about 3a? What looks different? It's a 3, so I'm looking for how many factors? 3 factors. So does it help me to find perfect squares anymore? What should I be looking for if I was going to do the expert way? Perfect cubes. Is there a perfect cube that works with 54? What? 27. So if I was doing the expert way, cube root of 27 times 2, yeah? What is the cube root of 27? 3. So what would come out? 3 cube root. What did I leave under there? 2. Expert way. Mr. Myers, I don't like that. Okay. This is also the cube root of 9 times 6, yes? No cube roots there, so I got to keep breaking it down, don't I? What's 9 break down into? No. 3 times 3. What does 6 break down into? 3 times 2. Hey, what's that right there? Is that a group of 3? So what comes out? 3. And what stayed under there? 2. Mr. Myers, I just don't see that one. I don't get it. No problem, kid. 54. 9, 6, 3, 3, 3, 2. There's a group of 3. So what comes out? 3. What stayed under there? 2. And I can't forget my little index. Everybody good? 99% of you are going to look at that and tell me the answer is 12, is it? Why? Because it's cube root of 144. So I need groups of 3, don't I? So, can't really do that, right? Hard to do the expert way. So let's break it down the blue way. I do know that's 12 times 12, don't I?
Yeah.
Any groups of 3?
No.
No. I do know that that is 3 times 4 and 3 times 4. Any groups of 3?
No.
No. I also know that's 3 times 2 times 2 times 3 times 2 times 2. Any groups of 3?
Yeah.
How many?
1.
1. 2 and 2. So what comes out?
2.
2. What stayed under there?
3
3 times 3
times 2.
times 2, which is what? 3 squared times 2. 3 squared is?
18.
9 times 2, 18. Everybody cool? Okay. What's really weird about C? It's a 4. So I'm looking for how big's the group now? 4. So I got to break it down. Damn, son. Well, I know that that's, oops, I don't want to use red. I know that that is 64 times 2, yeah? Right? So let's break down 64 again. That's 8 times 8 times 2, isn't it? I don't see any 4s. 2 times 4 times 2 times 4 times 2. Oh, we're getting close now. There's a group of 3. I want 3. What do I want? 4. Better break it down again. What's that 4 become? 2 times 2 times 2. What's that 4 become? 2 times 2 with one last 2. Now, is there any group of 4 in there?
Yeah, there's only 1.
There's one group of 4. So what comes out? 2. 4th root. What did I leave under there? 2 times 2 times 2, which is 8.
So how would I know? What if I didn't know 64 times 2 made 120?
You would have to do the long way. Since it ends in 8, it divides by 2. 2 goes into 12 6 times. And 2 goes into 8. There's none left over. 2 goes into 8 4 times. So 2 and 64. Then you would break 64 down using factor trees that we've already done. Okay. This one I can do easily because I know that that's 81 times 2, yes? And I know that 81 has a 4th root. It's 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So I can stop there because I know that's 3 4th root 2. How many of you could stop there? Probably not many. So you break it down. 81 times 2. Nothing there. 9 times 9 times 2. Now some of you could stop there because right there you're going to see, oh, that's 3 and 3 and that's 3 and 3. There's my group of 4. But if you don't see it there, you would break it down again. Oh, there's my group of 4. Out comes the 3, 4th root, and a 2 was left under there. Is everybody good? So, all that changes, the only thing that changes is the size of the group you're looking for. Right? Other than that, you can break these down any way you want. If you like factor trees, you're going to use a factor tree. If you can recognize what's happening here, you're going to use here. If you practice a bit and you start seeing some of the bigger roots, you can go right to here. Okay? But is there any difference between all 3 colors? No, because in every single one, we are always breaking down the radicand. It just is longer. What's 108 break down into?
They all divide
54 and 2. Right? It's a cube root. No cube roots there. What does 54 break down into? I would use 2 and 27. Why? 27 has a cube root. What is it? 3. So what comes out, Aaron? 3. And what stayed under there? Which is? 4. Now, again, if Joseph wanted to make 54 9 times 6, right? Okay, still nothing. 2 times 9 is 3 times 3. 6 is 3 times 2. There's your group of 3. Everybody cool?
No, it was 54 times 2 and divide the 108
By 2.
Okay. 10 times.
What's different between E and F? Squared. So I'm looking for groups of 2, aren't I? Well, I've already done it right here, haven't I? What's the group of 2? There's a 2 coming out.
So it's
2 and 2. And
a 2
a 3 coming out.
and then just 1 3.
What do we do with them?
You leave you times them.
Multiply them 6. And what did I leave under there?
3.
A 3. Can everybody do it?
Sure, yeah.
All right, your work tonight is page 98, 99, and now listen to me carefully. Please look at page 100. Please notice I have asked you to do 8 of what we just did. Yes? What if you understand it? Do you need to do all 8? If you are feeling like total green light, like why are we still talking about this right now, Mr. Myers? Shut up. Then do you need to do all 8 of these? No. Should you do some? Who decides how much you need before you get it? You do. So use your brain on page 100. The answers are there. If you're really good and you're confident, please notice that the screen is split, right? If you're confident with this stuff on the left, you'll notice the work gets harder the higher the number is. So if you think you're actually, Mr. Myers, I think I got page 100. I am all up in that thing. If you are, then you can do all of those. If you can't do all of those, you're not as good as you think you are. Everybody understand? And you will notice I am giving you more practice, but giving you more freedom to choose how much you do. It's a trade-off. If you abuse that privilege, what will happen to your grades? They will start tanking. If what you heard from me right now is, Myers said don't do it all, then your grade is going to tank. If what you heard was what I said, practice as much as you need to be good at this, then your grades will be awesome. Do you understand the difference in those 2 sentences? Good. Go.